Hey students, this is Coach Holiday, and today's lesson we're going to continue with the last lesson where you learned about greatest common factors and finding a greatest common factor. And today we're going to start actually factoring by pulling out a greatest common factor. Alright, so if you go ahead and pull out your notes packet and we'll get started. The procedure for doing this to factor with the greatest common factor is there's three steps. The first thing you're going to do is you're going to find the GCF, or the greatest common factor, for each term that's in your polynomial. After you do that, that GCF that you pull out will be the first factor, and the leftovers are going to be the second factor. So if you'll notice, I've got this written down here. It's going to look like kind of like this. The GCF will be your first factor, and you'll put it in parentheses. And then the leftovers will go in parentheses and be your second factor. So you'll have the GCF times the leftovers. Okay? So I think the best way to get going on this is to look at an example. So let's go ahead and look at example 1 and just kind of work through it and see how it goes. Alright, we want to factor using GCF. We're going to factor 15m squared minus 9. So the first thing is I want to find the greatest common factor of those two terms in this binomial. So what I'm going to do is I'm going to take 15m squared and I'm going to factor it into its prime factors. So things that multiply to make 15 are just basically 3 times 5. And you can't factor either of those any further, so they're prime, so we're going to leave them 3 times 5. And then I have m squared, so that's 2m's. And then I have my minus, so I'm going to put the minus here, and then the 9. And the factors of 9 are just 3 times 3. Alright? Now what I'm going to do is I'm going to look and see what they have in common. I'm going to circle those. So in the first term, my 15m squared, I have a 3, and I have a 3 in my second term, 9. The first term has a 5. There's no 5 in the second term. The first term has m's. There's no m in the second term. So what I've pulled out of each of this is a 3. Alright, so my GCF is going to equal 3. Because they each have 3 as a factor, and that's the only thing they have as a factor. My leftovers are going to be what's remaining. A 5 times a m times a m minus a 3. So I'm going to put these together. 5 times m is 5m squared minus, and I have a 3 left. That's my leftovers. So now what I'm going to do is I'm going to put the GCF as my first factor. So it's just 3. And I'm going to put it in parentheses. And then my second factor is the leftovers. The leftovers are my second factor. And I'm going to put those in parentheses. So 5m squared minus 3. And put that in parentheses. Now this is my factored polynomial. I can check this by multiplying back together. Since this is just a monomial times a binomial, I'm just going to distribute that 3. So I'll go 3 times 5m squared is 15m squared. 3 times negative 3 would be minus 9. And that's where I started out. So my solution, or my factored polynomials, would be right here. 3 times 5m squared minus 3. Okay, let's look at example 2. We want to factor using GCF 4w to the 5th minus 6w to the 3rd plus 14w. So the first thing is we're going to find our GCF by writing out the factors for each term. So I'm going to find the factors of 4w to the 5th. Well, the factors of 4 are just 2 times 2, and w to the 5th would be 5w's. Then I have a minus, and then I have factors of 6. 6 is just 2 times 3, and then I have 3 w's, w to the third power, or w cubed. And then I have a plus. Then I have 14w. The factors of 14 would just be 2 times 7, and then I have a w in there. So now I want to see what does each one of the terms have in it. So the first term has a 2, so does the second, and so does the third. First term has another 2, but there's no 2 in the second or third term left. The first term has a w, so does the second term and the third term. The first term has another w, the second term has another w, but the third one doesn't. So we're done with our factoring out. So our GCF is 2 times w. Our leftovers are going to be what's remaining. So in our first polynomial, our leftovers, we have a 2 w, 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 w. So that's 2 w to the fourth, since there's 4 w's there. I have a minus 3, and I have 2 w's, so 3w squared, and then I have a plus, and then I have a 7. So that's my leftovers. If you'll notice, everything's got a circle around it up here now. So my final factored answer is the GCF is 2w, and then the leftovers are 2w to the fourth minus 3w squared plus 7. And that is my factored form. Sorry about that. That's my factored form. So I can multiply to check, and I want you to check these, okay? So we'll check it. Since this first one is just a monomial, all I have to do is distribute it back into this trinomial. Okay, so I'll go 2w times 2w to the fourth is 4w. w to the first times w to the fourth is w to the fifth, minus 2w times 3w squared will be 6w, and I add those, 1 plus 2 is 3, and then the last part is plus 2w times 7 is 14w, and this is my original problem before it was factored. So it looks like that I factored it correctly. Alright, one more example. Negative x to the fifth minus 3x to the fourth plus 14x to the third minus x. So we'll start out by finding the greatest common factor by factoring each of their prime factors. Alright, so I have this minus to start with. So since it's with the first term, I got to really make it a negative 1. And then I have 5 x's. Minus 3. I could have done plus a negative 1 times 3, but I'll just do minus 3. And it's got 4 x's. Plus, let me fix that. There's an ugly plus there. Plus 14x to the third, so 14 is 2 times 7, and then 3 x's. And then minus, I just have an x. Alright, so let's find the GCF. So the GCF, the first one has a minus 1. There's not a minus 1 in all of them, so we don't need that. There's an x in the first one, an x in the second one, an x in the third one, and an x in the last term. So that's part of our GCF. There's another x in the first one, another x in the second one, another x in the third one, but there's no more x's in the fourth one. As a matter of fact, everything's gone from the fourth one, so I know my GCF is just going to be x. Okay, so now my leftovers are just what's left there. So I have negative 1 times x, 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 so 4 x's, so it's x to the fourth, minus 3, and then 3 x's, so 3x to the third, plus 2 times 7 is 14, and then I have 2 x's in that one, x squared, and then minus, now there's nothing left there, but I could have said it was times 1. So I want to go ahead and put the 1 there. If you'll remember in our previous lessons, if there's 4 terms in the original polynomial, then in the leftovers, when I divide out the GCF, there has to be 4 terms also, so I can't forget that minus 1. Right, so now our GCF is our first factor, that's x, and then the negative 1x to the fourth minus 3x to the third plus 14x squared minus 1 are my leftovers. And there's my factored polynomial factoring out of GCF. I could check it. I want you to go ahead and do that on your own by distributing that x into all 4 terms. And when you do that, you'll get the original polynomial. Okay? So hopefully you understood that. We'll do some practice on this in class tomorrow. Go ahead and make sure that you complete the WISC and you've taken good notes on this, and be ready to talk about it in class tomorrow.